Hey everyone, and welcome. Today, we're tackling a LeetCode problem that's all about building a core piece of software, a spreadsheet. We'll design a class from scratch that can set values, reset them, and even compute simple formulas. Let's break it down. Okay, so the goal is to implement a spreadsheet class. Imagine a grid with columns labeled A through Z, and a certain number of rows that we specify when we create it. Every cell in this grid can hold a whole number. We need to implement a few key functions. First, the main spreadsheet function itself, which acts as a blueprint to initialize a new spreadsheet with a given number of rows. Then we have two straightforward actions: setCell, which lets us assign a value to a specific cell like A1, and resetCell, which just clears a cell out, setting it back to 0. Now for the interesting part, the getValue function. This one takes a string that looks like a formula, for example equals x plus y. Here, x and y can be either references to other cells like A1, or they can be simple numbers. An important rule is that if we try to get the value of a cell we've never set before, we just treat it as 0. Let's walk through the example to make this concrete. First, we create a new spreadsheet with 3 rows. Then, we set cell A1 to the value 10, and cell B2 to 15. Now, if we ask to get the value of equals 5 plus 7, well, that's just simple addition, giving us 12. If we ask for equals A1 plus 6, the system fetches the 10 from A1 and adds 6, returning 16. Finally, equals A1 plus B2 will grab the values from both cells, 10 and 15, and sum them up to get 25. So how do we build this? The most direct approach is to simulate the spreadsheet. We can use a two-dimensional array, basically a list containing other lists, to model the grid of cells. A key part of this will be a helper function that can translate a cell name, like the string A1, into the array coordinates, like row 0, column 0. For the getValue function, we'll need to pass the formula string to figure out what two things we're adding together. Alright, here's the full Python code for our simulation approach. Don't worry, we'll break down the important parts on the next few slides to see exactly how it works. First up, the setup. Inside our spreadsheet class, the initialization function creates our grid. It's a list of lists, filled with zeros, with the specified number of rows, and always 26 columns. Then, we have our private helper method, parseCell. This little function is crucial. It takes a string like B3, calculates that B is the first column since A is 0, and that row 3 is actually index 2 because of 1-based indexing. It then returns these coordinates. The setCell and resetCell methods are now very simple. They both use our parseCell helper to convert the cell name into a row and column. Then, setCell just assigns the new value to that position in our grid, while resetCell simply puts a 0 there. Easy enough? Okay, here's the brain of the getValue function. We create another helper called getOperandValue, cosa. Its job is to take one part of a formula, like A1 or 5, and figure out its numerical value. It checks if the first character is a letter. If it is, we know it's a cell reference. We parse it, find the value in our grid, and return it. If the operand doesn't start with a letter, we assume it's a number, so we just convert the string to an integer. Now, the main getValue function becomes a manager. It first strips off the leading equals sign from the formula. Then, it finds the plus sign to know where to split the string. It breaks the string into two operands, operand 1 and operand 2. For each of these, it calls our helper function, getOperandValue, to get their numeric values. Finally, it just adds those two values together and returns the result. So how efficient is this solution? When we create the spreadsheet, the time it takes is proportional to the number of rows times the number of columns, because we have to initialize every single cell. The space it uses is also determined by the total number of cells. For our other functions, setting a cell, resetting it, or getting a value, the time complexity depends on the length of the input string, because parsing isn't entirely free, but it's very fast in practice. We can think of it as being nearly constant time. Let's wrap it up. For a problem like designing a spreadsheet, using a two-dimensional array is a very natural and effective way to represent the data. Creating small, focused helper functions, like the one we use to parse cell names, makes the main code much cleaner and easier to read. And finally, when faced with a more complex task like parsing a formula, breaking it down into smaller steps, like splitting the string and then resolving each part individually, makes the problem much simpler to solve. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more LeetCode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Hope this LeetCode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.